Hello, this is Mrs. Ross, and this is the 5.6.1 Circular Motion and Gravitation Unit Test Review. All right, this first question, I used lesson 5.1 in page 19 of 34. There's a part of it that says the velocity at each point is tangent to the circle. So I chose D. Okay. For this one, I used independent practice on page 32 of 34, lesson 5.1. It says a windmill has 3 rotating blades. The tip of each blade traces a circle every 4 seconds. The quantity 4 seconds is the measurement of the blank of the blade, and it is the period of the blade, which is the time it takes for one rotation. Okay. Okay. So what I did here was I said, okay, so A is equal to V squared over R. It says a car is traveling at constant speed V across a flat road. The first road curves in a circular arc of radius 2r, and then curves in a circular arc of radius r. As the car travels from the first curve to the second curve, how is its centripetal acceleration affected? So the first curve has a radius of 2r, and the second curve has a radius of r. So to get from here to here, I have to multiply by 2. Excuse me. So I said that it doubles. This is the same as the last one. So I got the answer for this one on lesson 5.1, the guided practice, page 15 of 34. It says, what best describes the velocity of an object that is traveling in uniform circular motion? Remember, velocity is a vector, so it has magnitude and direction. So the speed is constant if you look at the diagrams, but the direction is constantly changing because it's going in this circle, and you have your velocity. The magnitude seems to be the same, but the direction is always changing. So I chose A. Okay, a particle travels in a circle of radius 82 centimeters with a centripetal acceleration of 4.7 meters per second. How long does it take the particle to do one revolution? So what I did was I said, okay, I have A is equal to V squared over R. I know that my R is going to have to be in meters. So, okay, so, excuse me, so this is 4.7 is A. I'm actually solve for the V squared 0.82. So V is going to be equal to 1.963 meters per second. And then I'm going to use this to find my time. So I plug in my this to over time, and I get 2.62 seconds, which is A. Okay, I'm going to change colors here. Okay, so this one, a race car travels at constant speed of 33 meters per second along a circular arc of 10 meters. What is the acceleration? We're going to use our velocity is 33, our radius is 10. We get 108.9 meters per second squared, which is D. Okay. This one, I worked several times and got a different answer than what they said. They said the answer was C, and I got D every time I worked it. So let me show you what I did. So they're talking about an aileron roll, and we have this acceleration, and this is going to be our radius. Maybe that's what I did. Okay, so I was just double checking my answer, and this is the one that I got. And when I double check it with some of the different answers online, that's what they get to. So I'm unsure why we have this. But let me show you how I got there. So I have V is equal to 2 pi r over T. And I'm solving for V in terms of T. Let me show you what that looks like. So I have 2 times 3.14 times 8.9 all over T. Which gives me 55.892 over T. Okay, then what I'm going to do is I'm going to plug it into this formula. And I know that this is 4. So I have 4 is equal to 55.892 over T squared over 8.9. So I multiply 8.9 times 4, get 35.6 is equal to this large number over T squared. So I got rid of this, and then I squared all of this. And then you have to multiply by T squared, divide by that, and square root, and I get 9.367 seconds, which should be D. Okay. And a Ferris wheel. Let's see. Okay. So this is from lesson 5.3, page 7 of 30, in the example of dynamics of a Ferris wheel. Okay. It talks about at the top and the upward force, the seat applies to the passenger is less or smaller, in magnitude than the passenger's weight. And that is that's this one. The other thing you need to know about this is not real. Centrifugal force, that's not a thing. So if you ever see that, that's a red herring. So it's either this one or this one. And this does not help. So I guess if we look at the free body diagram, force centripetal and your weight. Whereas down here at the bottom, these would be... Okay, so I could see where we could get a... But centrifugal force is not a thing. Centripetal force is a thing. Okay, let me change colors. Okay, so we have... consider a cylindrical space station that rotates with a period of 28 seconds. Acceleration is that of Earth. It's here. And we're trying to find the diameter of the space station, which is 2 times r. So I used, let's say F is equal to ma, which is equal to mv squared over r. And then I just started writing some, as this is this. Velocity is distance over time, which is going to be 2 pi r over 28 seconds. So then I plugged in some stuff. So I have 9.8 times m, so I used my acceleration there, is equal to m times 2 pi r. Now this is the orbital velocity, radial velocity, etc. 28. That's squared over r. Okay, so my m's are going to cancel. I get, and I'm going to multiply both sides by r, so I get 9.8 r is equal to 2 pi r over 28 squared. Okie dokie. And I get 9.8 r is equal to, when I figure all of the numbers out here, I get 0.50 r squared. So one of my r's is going to cancel. I have 9.8, 0.050 r. And I get r is equal to 194.81 meters. So I have to plug that in because it's looking for diameter. And I get 389.63 meters, which is B. Okay, this was fun. As shown, 2 massless wires. Okay, so this is 7.2 kilograms. Okay, so what I did was I said, okay, I drew my little triangle. And I said that this is going to be ft cosine 60 degrees. And this is going to be ft sine 60 degrees. And then I drew another triangle. And I said, this is going to be ft cosine 60. Okay, keep in mind, this 60 is in a different spot for this triangle. So, and this is ft sine 60. Now, tension is the same in both wires. It says right here. Excuse me. So what I did is I did a free body diagram of the sphere. And I said, okay, everything acting in the y direction. I have my force of weight. And then I have my ft sine 60 degrees, which is here, and I have my ft cosine 60 degrees. So I said, all right, my force of weight is going to be equal to ft sine 60 degrees plus ft cosine 60 degrees. So this is 7.2 times 9.8. And what I did was I took the sine and I took the cosine and I added them. So I have this much force tension. And then I solved for force tension is equal to 51.65 newtons, which is C.